Orbiting 250 miles above Earth, a giant laboratory floats silently in the vacuum of space. It's one of the most ambitious engineering feats ever attempted. The International Space Station, ISS. Its achievement is not only limited to the space exploration, but other areas of science as well. But how did this massive structure come to be? Who built it? And why? In this video, we will talk about the journey through the history, motive, operation, and science behind the International Space Station, ISS, the largest human outpost beyond Earth. The roots of the International Space Station trace back to an unlikely beginning, the Cold War. During the 1960s and 1970s, the United States and the Soviet Union competed fiercely in the space race. But by the 1980s, the idea of collaboration began to emerge. But how? Let's dive into it. In 1984, US President Ronald Reagan announced plans for a permanently crewed space station, inviting allies to join. The US Congress passed the budget for a space station in 1984, the same year, and NASA started looking for international partners to participate in the project. Canada, Japan, and many nations of Europe joined the program almost immediately. The ISS was designed between 1984 and 1993, and the construction started in the late 1980s. The parts of the space station were built throughout the US, Canada, Japan, and Europe. But in 1993, the space station design needed a review and change. It became too costly at a point. Then Russia was invited to join the construction of the space station. As you can imagine, the design and construction of the ISS happened during 1980s and 1990s. The tension from Cold War was still there. But due to the cost and complexity of the project, it became clear to go further, nations would need to work together. At first, the US program was called Freedom. In parallel, the Soviet Union was operating Mir, a modular space station. But after the Cold War ended in the early 1990s, former rivals joined hands. Both US and Russia had experience building space stations, the US with Skylab and the USSR with Salyut and Mir. At this point, it was even a bigger and stronger collaboration. The United States, Russia, Europe, Japan, and Canada formed an international partnership. In the agreement, there were two phases. The phase 1 ranged from 1995 to 1998, called NASA Mir, was for NASA to carry the astronauts and cosmonauts to the Russian Mir orbital station. A little bit about Mir space station. Mir was launched on February 20, 1986 from Kazakhstan in low Earth orbit. It deorbited and crashed into the Pacific Ocean on March 23, 2001. Getting back to the phase 1 of ISS, the US helped Russia to modify two Russian-built modules of Mir, Spectre and Priroda, with dozens of US payloads and 7 US astronauts. These two modules eventually became a part of Russian orbital station Mir. In that time frame, 11 space shuttles went to Mir and 10 of them docked to Mir when astronauts and cosmonauts transferred between the two vehicles. In the phase 2, starting in 1998 and led by the US and Russia, all the participating nations were to provide with the elements and crew members to a new international space station. Each partner was responsible to maintain and manage the hardware they provided. Today, the ISS is a symbol of what humanity can achieve together. It's operated by 5 space agencies: NASA of America, Roscosmos of Russia, ESA of Europe, JAXA of Japan, and CSA of Canada. Over 250 astronauts from nearly 20 countries have lived and worked there. Robotic arms built in Canada, Japanese cargo ships, European laboratories, Russian propulsion systems, all assembled into one working spacecraft orbiting Earth every 90 minutes. Let's take a slightly deeper dive into some major pieces. In 1998, after years of planning, the first piece of the International Space Station or ISS was launched. The first module, Zarya, was Russian-built and launched in November 1998. Just weeks later, the American module Unity was added. From there, the station grew piece by piece like a Lego set, using complex robotic systems and highly skilled spacewalking human astronauts and cosmonauts, carried into orbit by dozens of space shuttle missions, Russian Proton rockets and Soyuz capsules, It became a global construction site in space, with astronauts performing complex spacewalks to bolt on modules, install solar arrays, and build laboratories. If you want to learn the details about all the modules, I have the link in the description box below. Please check. ISS is the largest man-made object ever orbit the Earth, with a pressurized volume of 900 meter cube and a mass of over 400,000 kilograms or 900,000 pounds. These numbers slightly vary as logistics resupply vehicles come and go on a regular basis. The frequency of these vehicles coming with the supply material is almost 8 or 9 per year. ISS has been continuously occupied with a crew of 3 to 6 members on board at all times since November 2000. A new crew typically arrives at the International Space Station every 6 months. ISS orbits at an altitude of between 370 to 460 km. It falls towards Earth continuously because of atmospheric friction. 2,247 meter square area is covered with the solar arrays in ISS that generate 735,000 kilowatt hours of electrical power per year. What do they do for water? ISS uses a closed-loop water system to recapture and reuse water from various sources. Water is collected from the crew's breath, sweat, urine, and condensation on the station's walls. The water recovery system, along with water processing assembly, processes wastewater and produces drinkable water. ISS also has a urine processor assembly that recovers water from urine vacuum distillation, according to NASA. Cargo vehicles also brings water to the ISS, which is stored in pressurized tanks and used as a backup supply. As you can see, it's a micro-city by itself, and building this took a different level of skill set. Besides the technical skills, working in the space is another skill. I mentioned earlier about the spacewalking astronauts and cosmonauts. During the construction of the ISS, more spacewalks or extravehicular activity happened than all the prior programs combined. In the prior space programs, spacewalks happened on the Earth orbit, Moon surface, and in the deep space between the Earth and Moon. What happens in the ISS? The ISS isn't just a space shelter. It's a functioning, highly capable microgravity laboratory constantly buzzing with scientific activity. Experiments conducted in the station help us understand how the human body reacts to microgravity, how fluids, combustion, and materials behave in space, monitoring Earth from orbit, collection of cosmic particles, and more. The research in ISS is not limited to the space exploration only. It also has major breakthroughs on the other areas like fifth state of matter, identification of unknown microbes in space, drug development using protein crystals, methods to combat muscle atrophy and bone loss, fundamental disease research such as Alzheimer's, Parkinson's, and cancer. Also, as we talked about earlier, new water purification systems. Please feel free to check more details about the major scientific breakthroughs that came from the ISS. You will find the link in the description box below. It's also a testing ground for future missions like sending humans to the Moon or even Mars. But the ISS won't last forever. It's expected to retire around 2030. And in its place, NASA is planning the Lunar Gateway, a small station orbiting the Moon. Private companies are working on commercial space stations. And the lessons we have learned from building and operating the ISS will guide us into the next era of space exploration. If you enjoyed this journey through history and science, be sure to like, subscribe, and click the bell icon. See you in my next video. Thank you for watching.